it's taken longer than I expected to get part 2 of this video up, but if you like this content, you know what to do, and it's already a long video, so without further ado, what's going on, ladies and gentlemen? Welcome to part 2 of the ERM 72150 conversion. A couple things have changed since last time, but not a whole lot. I'm keeping you guys in the loop, don't worry. Put the rear sprocket on, that's nothing too exciting, but did manage to get the motor controller all mounted up. So, like I said, I took this sheet of aluminum, I clamped it, I traced out the edge of it, which you can still see the Sharpie mark here, cut it out, follows the contour pretty nicely, and then I bolted it in 4 places, 2 on this side and 2 on this side. And then the controller itself is mounted in all 4 corners, and yeah, it's not going anywhere. Rock solid, which is awesome. Additionally, I began wiring up the throttle, which in the case of this throttle right here, I don't know the particular model and all of that, it's a little bit annoying. The other thing I'm going to try and do today is mock up some more wiring so that I can actually get the motor spinning. So I'll take the controller out of the frame and I'll lay everything out on a table, and then we'll try and get that baby to spin. So don't know if that's going to happen in this part of the video or not yet, but without further ado, got some soldering flux, got some solder, wire, and here we've got some more Anderson connectors. So I need one of those, and the lugs that actually get inserted into here. And then for all of the other terminal connections, I have these copper lugs. So let me just get this set up for a moment. Okay, so while I don't have the total picture here, this is pretty much what we've got going on. So I came over here and I'm like, alright, this is where I'm mounting my battery. Things coming out of it. Where's the furthest place I want to put the fuse away? And then where's the furthest place that I want to integrate the cutoff switch? And then based on that, I just pretty much overcompensated with the wire lengths, because even though I have plenty of spare wire here, I'd rather keep it for future projects maybe. So, let's say I only need half this length. Well, this guy is a lot cheaper than buying more wire. So I'd just cut off that length, put on a new connector, and then I'd have the length I want. And so here I just kind of have like a little symbolic representation for what's going on. So this will connect into the battery, and then following the positive lead, we're going to have this 250 amp fuse in line with the positive. Then we're going to run down, and then I couldn't even turn the motor on today if I wanted to because I don't have my cutoff switch. I left it at my apartment. But this pre-charge resistor is going to go across that cutoff switch, and that'll be my main disconnect to the battery. And then this is the wire that's going to be running from wherever the cutoff switch is over to the positive side of the controller. And then the negative is super simple. We just have to go from battery to the controller. So I actually think I cut that way too long, because there's no sense in me mounting the battery such that the connector's down here where mud and dirt's going to get splashed on it. I'm going to orient it this way. And so really I only need the length to be from here to here. And, case 3 or 4 or whatever the hell, me being an idiot, was acting like my negative had to run from here. I don't know why. Just a minor glitch in my brain. So next thing I'm going to do is make all these connections. I'll show you guys what I'm doing there. Okay, so the first step is just going to be to figure out how much of this wire I need to strip. So I just come, put this up here. Alright, stick my thumb right there. And then carefully strip the wire. If you go too far, then you're going to lose strands, and then you're going to have more resistance. We don't want resistance. Just really taking my time here just to kind of gar the surface of the insulation without cutting too deep. Not the cleanest thing with these as opposed to a real wire stripper, but you know, this is a budget project. Okay, so we're back here a little while later. Let me tell you, this is not as easy as the dude made it look in his video. At any rate, got some soldered connections on here. I tried one with this style lug that's going into the Anderson plug crimped and one uncrimped. I think crimping it first is more ideal. And so that's what I ended up doing with the copper ones as well. They certainly don't look nearly as pretty after you heat them up and get tin all over them. But after crimping them, with the copper it's super easy. You can just put it in the vise, turn it by hand, and crimp it until you can't pull it out. And then I just came to this flat here, and I put the punch on and used a hammer, and then just put a mark on each side, if you can see it, just to make that even a little bit more solid. And then I would clamp this into the vise, like so, heat up the lug. Don't heat up the copper wires because you don't want them to oxidize. You want to heat up the lug and then let the solder flow in. So yeah, I don't know if I mentioned already, but you need to put some of this flux on the end of the wire before you stick it in and crimp it so that all of the solder can flow nicely into the lug. So hopefully that's helpful for any of you guys who haven't done a project like this before. You know, doing the soldering isn't totally necessary, but it does make it so that there's less of a voltage drop than if you just did a regular crimp connection. But a regular crimp connection would work just fine as well. Wow, okay, that is definitely the best looking one I've done so far. And I think really the key was not having too much of the flux sitting out around the rim, because then it drips down and actually catches on fire. And it's pretty, I think it's normal, but you do need to burn out all of the flux because it's acidic. And so if there's flux left in here, then it will over time corrode the cable. So, you know, you need to make sure you fill this all the way up with solder and that it is all coming out of there. But yeah, this one looks really good. Hopefully I can do some more like that. Okay, so now I have all of the cables made up. Now I'm just applying some heat shrink over these. Hopefully help from keeping the exposed copper from corroding. Might be hard to see. Yeah, but if you can see how it's kind of shiny right there, I bought this heat shrink that has a glue in it so that it's weatherproof, so no moisture should be getting through this shrink wrap and into the copper wire. So I'm just going to finish heat shrinking the rest of the connections, and then I'll kind of show you what this looks like when it's all hooked up. Here we are again, the same configuration. I've actually got these guys hooked up into there. This will go to the negative terminal on the controller. This will be connected to the battery, go up to this fuse. next day or so, I will grab the battery disconnect, and that'll go in there, and the pre-charge resistor will go across there. This will go on to the positive terminal of the motor controller. I should be all set. Doing a little bit more wiring today, actually. This is the same plug that I've hooked up for the battery charger, but this one is going to be used for this puppy. Yup. Got myself a mill drill. So, yeah, we're going to be able to make some real cool shit with this. My brother and my mom's boyfriend worked on making this stand while I was doing the fabricating of that mount there. So yeah, with this I'll be making them out for the LCD. That's what I'm going to make all of the brackets with for the motor, and so level of precision should be high. Looking forward to it. Well, as expected, I haven't gotten this going yet, so I'm going to have to consult Endless some more. I don't really know what I'm doing wrong, you know? I got the throttle hooked up, I've got the battery positive and minus, the controller power's up, so I know there's power to the controller, and I have that E-lock hooked up, which, like, it's stupid how they do this, because the E-lock's purple and gray, and they label it that, but then there's multiple other things that are purple and gray wires, so I don't know. I'll figure it out. Well, it seems like the best thing for me to do is to go ahead and hook this up to my laptop and try and program it. Only thing is, my laptop was having issues from the people I just bought it from, and it's still getting fixed and won't be ready until tomorrow. So, in the meantime, I'm going to make a longer battery negative cable because this thing is just way too short. So, I'll take care of that, and I will see you guys once my laptop is hooked up to this. So, remember when I said I hope this wasn't going to be a long and arduous process? Well, here we are. But I've cleared some faults on the program. I did a trick that's in the 55-page long Endless Sphere thread with over 1,000 posts that I've pretty much entirely read at this point. And I'm going to turn this controller back on, and dear God, do I hope it works. Oh, geez. Well, I'm still getting a blinking light on the controller, so probability is low. Holy shit. That is the weakest spin I've seen in my entire life, but I'm getting somewhere. Okay, so super weak spinny thing, right? Come and look at the program. Look at this crazy voltage drop. I don't know what it is with this thing, but I tested with my multimeter, and I have pretty much full battery amps, you know, up until here, and on this side of that switch, and then on the other side, it's just horrible. I mean, it drops like crazy. So I'm gonna go ahead and disconnect that and try again. It worked. It actually worked. The thing was that I actually just had the switch in the wrong bleepity position. So it's, you know, it's not my fault. I swear to God, I can't even show you. You see how the on arrow is to the left and the off is to the right? Well, I thought the on position, you know, to the left would, you know, mean voltage is going through it. Nope, it's the off. So, pretty easy fix there. So I was able to get the motor spinning up to a couple hundred RPMs, but I think it's got to be something to do with either the fuse I've chosen, but that didn't blow, so I really don't think it's that. I think it's got to be this guy. Maybe it's some effect that the resistor has. Not really sure. Unfortunately, I gotta leave here for today. But yeah, super promising. At least I know how to get the motor spinning. I just gotta figure out what's causing this voltage drop to be so ridiculous. Because I have while I was doing it, I had the Bluetooth application open for the battery. The voltage sag was 5 thousandths of a volt, and then over here we're dropping from 73 to like 50 all of a sudden. So it's got to be one of my components. If it's that controller, I'll be pissed, but we'll see. So now I've made another change to this circuit since one of the earlier takes I had. So before, I had this resistor going directly across the cutoff switch. Well, that was bad for two reasons. One, since that resistor was going across there, even though this cutoff switch was off, it was allowing some amount of current to pass through to the controller all of the time. And so if I had permanently set up the bike like that and forgot to turn this off, or actually even if I did turn it off, then it would still be constantly draining the battery, and that could be a bad thing. Second thing is that as the current's passing through, it also would have to pass through the resistor, which I think was causing, would end up causing excess amounts of resistance. Maybe not. I don't know. I'm not an electrical engineer. I'm a mechanical engineer, okay? So what I did was went on Amazon and I bought a momentary switch, and I bought another resistor that actually had they kind of look like these, but smaller and just bare metal on each end of here. So that way I could actually strip the wire, wrap it around there, and then shrink wrap over it and keep it in place. With this one, there's no way. I mean, I guess I could have wrapped a wire around this, but it just wouldn't have worked out nearly as nicely. And so, without further ado, I'll show you kind of how this works. So, let's see. Right now, the program is showing 11.4 volts. So I'm going to come over here to my momentary switch, and I'm about to press down on it. You have to click open, and then connect. And then if all is well, not all is well. Okay, so back to showing you guys how this works. Don't know why, just kind of had to unplug this and replug it in. So we're showing 72.5 for our voltage right now. Before, if I just turn the cutoff switch, it would only go down to like 66.6 because, current was passing through here, and this was, well, not that, but this was allowing current to pass through and, was letting the voltage rise in the capacitors, charging those up. So now when we switch it off, okay, switched it off from here to there, the voltage just keeps dropping, right? Now if we come over here, press down our little momentary switch, because right now, no electricity can pass through here anymore until I hit this and make the connection. Okay, so 3, 2, 1, and starts climbing. So really I could just wait like 5 seconds, but probably safer to wait about, 10, which is right now. And then I can go ahead, set my phone down for a sec, switch on that. Let go of this guy, and now that's no longer part of it. And we can use our throttle, and you guys can watch this spin. Alright, just a second. Yeah. I don't know where this torque came from all of a sudden, but yeah, that's awesome. I just don't want to damage those wires not being able to hold on to it. So, there you guys go. That is going to be the end of part 2. I apologize if this ends up being a longer one. I'm sure it will. But yeah, I feel like that's a good stopping point. We've got the motor spinning. Next part of the series is going to be, you know, figuring out the mounting of the motor and machining those parts, and then maybe some other little tidbits and content in there. And then the third part will be about the battery and modifying the frame and doing all of that work. And then hopefully number 4 will be us riding that shit. So with that, peace out, guys. Take care. Stay COVID free.